Hello guys, what's up? We're going to present a video presentation before you on thermal conduction. Thanks to our Honorable Mr. Faisal Mansur for giving us the opportunity to present this. At first, the question arises, what is thermal conduction? In brief, thermal conduction is the transfer of internal energy by macroscopic diffusion and collisions of particles or quasi-particles within a body. And the macroscopically diffusing and colliding objects include molecules, atoms, and electrons. They transfer disorganized macroscopic kinetic and potential energy, which are jointly known as internal energy. It spontaneously flows from a hotter to a colder body. In the absence of external drivers, temperature differences decay over time, and the bodies approach thermal equilibrium. In conduction, the heat flows within and through the body itself. In contrast, in heat transfer by thermal radiation, the transfer is often between bodies, which may be separated spatially. Also possible is transfer of heat by a combination of conduction and thermal radiation. Four kinds of thermal conduction: steady-state conduction, transient conduction, relativistic conduction, and quantum conduction. And the law of heat conduction, also known as Fourier's law, was developed by Joseph Fourier, and the law is Q by A equal to minus K dt by dx. And here is a graphical representation of the mathematical form of Fourier's law, and the bar is drawn where a ball is represented and the path of heat conduction is shown from hotter to colder side. And here we can see a picture on how heat energy Q passes through a metal bar with time t. If we assume the temperature of the 2 points of the bar as T1 and T2 consequently, then if T2 is greater than T1 and the area of the bar is A, then the heat will pass like this pattern shown in this figure. The steady-state methods are used when the materials are in equilibrium state, means the temperature of the materials are constant. And the transient state method is used during the heating of material. And here is another figure where you can see a cross-section of a cylindrical bar where the temperature difference is denoted by theta and is calculated by subtracting from one temperature and the other, where time is a factor to affect the transfer rate of heat. Another figure to show you about the molecular vibration caused by source of heat to conduct heat. If you conduct air as a medium of heat conduction, then the red dots show the heated molecules while the blue dots represents cold molecules. Gradually, blue dots are going to be heated by conduction method. The figure shows the difference between the possibilities of transmission of heat while cooking. The handlebar of the saucepan is transmitting heat by conduction process. Water boiling inside the pan is absorbing heat from the fire by convection process, and the fire is emitting heat from the surrounded environment by radiation process. And in the same way, the molecule in the hot cup of liquid transfer their heat energy to the molecules in the cold spoon gradually. And here is another figure. This figure shows the thermal conductivity of different material on how well the material conducts heat. Water is in some kind of neutral position where fiberglass insulated styrofoam cup is reluctant to conduct heat. On the other hand, metals show a high conductive property as heat they can contain conducting or floating electrons. At this time, question may arise in your mind about the application of all this heat conduction. Explanations? Okay, here's the answer. The two major applications of thermal conduction is splat cooling and metal quenching. Splat cooling is a method for quenching small droplets of molten materials by rapid contact with a cold surface, and the metal quenching is a transient heat transfer process in terms of the time-temperature transformation or T. And lastly, a slightly complicated but relief-oriented heat conduction example is shown in this figure where the absorption rate of different materials should be calculated to get the final temperature difference between the two sides of wall of a home. And in the graphical body of the thermal conduction at the right side, you can see the thermal bridging effect through the stars. Thank you, sir, and everyone who have watched this. If you have any question regarding this presentation, you can mail us at showvictorctg@gmail.com. Thank you.